Okay, let's get started with the chapter 9 homework, which is over here. So chapter 9, 5 questions. These are all two proportion Z hypothesis tests or confidence interval. So here it shows you what you need to do. Okay, so if you watch the video, you have a little idea of what's going on here. So let's go ahead and read this problem. Now, if you need to pause the video and read it and come back, you could do that. I'm looking for a claim. So the claim is that men and women have equal success, okay, when challenging these calls. So whenever the claim is that it's equal, that's an indication that your alternative is a not equal to. And that the null hypothesis is an equal to. You should get comfortable writing this out instead of just looking. So we're looking at this one right here. That's always step 1 of your hypothesis test. Okay, now they're probably going to have me get a test statistic. Okay, so to get the test statistic, this is step 2. You have to know what test to run. So how did I know this was a proportion test other than being a 9.1? When somebody challenges it, they're either going to be right or they're going to be wrong. So the data is there was this many calls, 1430 calls, and 431 of those calls were overturned. So on each call, it was either overturned or not overturned. That's what makes it a proportion. The data itself is categorical or qualitative. They're like yes/no situations versus like real number data, like a height or a weight. Okay, so since it's a proportion, all proportions are done under prop stat. There's 2 samples because we have our data from the guys and the girls. Okay, we don't have the data, we have a summary. Okay, so let's go ahead and put this in, the number of successes. Okay, so 431 were overturned out of, okay, that was men. So men challenged 1430 and 431 were overturned out of 1430. Okay, for the females, they challenged 764 and 214 were overturned out of 764. And before you get lost and you're not really sure, I didn't mean to do that. Darn it. That was an accident. How about that? I gotta do that again. Just bear with me for a sec. Oh, they went away. Okay, 431. Sorry, I lost the, I accidentally hit the button. Okay, so what I was saying is, just to get you an idea of what we're doing here is we're trying to show that the true rate is different. Okay, so I'm gonna calculate the sample rate. I'm gonna calculate the differences in the sample fractions, and then to give you an idea of what this test is gonna be doing once we run it. Just waiting for my calculator to show up here. So we're gonna have, there's 2 fractions. There's the fractions of the guys that were overturned and the fraction of girls that were overturned. Okay, so make this a little bigger. Stay away from there. Okay, so the fraction of guys that were overturned was 431 divided by 1430. Okay, so they had roughly 30% overturn. Well, what about the girls? 214. They had 214 overturn divided by the 764. They had about 28%. So the guys had about 2% more overturn. Now, is that enough to say that the true rate is different? We have to run the test. So I have the data in here. That's my null. That's my alternative. And compute to get the z-score. So 1.04. We have to go to 2 decimals. 1.04. Okay, now the p-value is this over here, 0.297. Okay, now the p-value is greater than the significance level. That's because this is around 30%, and that's 5%, and 30% is bigger than 5%. Okay, so whenever the p is large, we're gonna not reject the null. And whenever we do not reject the null, there is not sufficient evidence. Okay, so that's the link. If there's the p-value is greater than alpha, we're not going to reject the null. We're not going to reject this, and in that case, we do not have we don't have sufficient evidence to warrant a rejection of the claim. Okay, so now to get the confidence interval, you just hit Options, Edit, go down here to confidence interval. Now the tricky thing about the it says 95%, so we could do 95%. And this is 95%, so compute. And then this is my lower. Which I think I could cut and paste on this computer. Okay, how many decimals? 3. So looks like I need to go to the 8. And to the 1. There you go. Okay, so if you watch the video on how to do this, you have to look for 0 in this, and 0 is there. That's a negative, that's a positive. Does include 0. So there does not appear to be a significant difference. Okay, so if 0's in there, we're basically saying that this difference could be 0. If that difference could be 0, then we could say we don't think that there's any difference. Okay, that's how a lot of them should look like. Guess maybe I'm not done. Okay, so whenever they talk about do they have an equal, based on the confidence interval, we really can't say that they're equal. We could say they could be equal. So let's go ahead and read this thing. Okay, B is definitely not true. The confidence interval does not suggest that there's a difference. Okay, and the last one's not true either. Basically, the confidence interval suggests that there's no difference because 0's in there. If 0's in there, we can't say that they're different. Okay, good. So go ahead and pause the video and maybe start over here. Okay, so they're doing a video on the proportion of people who dream in black versus in color. So I'm looking for a claim. So we want to test the claim that the proportion of people over 55 who dream in black and white is greater. Okay? So the proportion of people over 65 black and white is greater than the proportion of people who dream in color. That's not the null, that's the alternative. The null will be an equal. Black and white. Okay, so whenever the claim is a greater than or less than or not equal to, that's going to go in your alternative, and your null is going to be the equal. So I'm looking for that one. It looks like the first one. Okay, now we need to find the z-score. And just like last time, let's see if we see a big difference in the proportion from our samples. The overall idea of the test isn't really about the sample. It's not about what happened with these people. It's about everybody. Okay, so in our samples, we have 10 over 310. So that's around 3%. Well, what about the people that are over 55 that drink? Okay, this isn't color. This is younger people to black and white and older people to black and white. Okay. I thought it was to color. So I'm going to talk about what separates these people just so we're clear on what the problem's saying. Okay, so this says 1055. So these people are over 55. And these people are over 55. These people are younger. So this is the under 25. And this is black and white under 25. I just want to make sure that you understand the problem. Everybody here is over 55, and over here, everybody here is under 25. They think that the proportion of people over 55 who dream in black and white is greater than the proportion of that dream in black and white that are under 25. Okay, so let me go back to this thing. 10 out of 310 are all these people are young people. So these are the young people. Now how about the older people? We have 78. I just want you to have an idea of what the test is actually doing out of 291. So this is the older crowd. Okay, so it seems like there's a way higher percentage in the, this is from the sample, by the way, in the sample data showing that there's a high percentage of older people that dream in black and white versus the younger people. Okay, so we're seeing really big differences in our sample, so most likely we're going to reject this null, which means the z-score is going to be really big. Okay, that'll be probably the last time I kind of go through in detail what's going on. I'll just do the test. Okay, now we want to put it whoever the first one was, which was the younger people, which was which was the older people, 78 out of 291. And the younger people were 10 out of 310. And my null, that should be a greater, because that should match that. Compute 8.17. I already know the z-score is going to be a 0. I don't really need to check it, or it's there. It's 0. It's over here. Okay, so the p-value is less than 5%, because that is less than 5%. So we're going to reject the null hypothesis. There is sufficient evidence to support the claim. We have evidence to support this claim. This is the H1. That's their claim. Okay, find the confidence interval. Just go back, change it to there. We want to change the 95 to a 90. And there's our interval. Three decimals, so that 9's gonna bump that up. I think that's right. And this one has to go to a 2. So I'm just rounding there. Okay, so whenever you get these intervals, we're looking for 0. I'm looking for 0 in there, and I don't see 0. So if 0 is not included there, then we're gonna think that they're not equal. Because if they were equal, 0 should be in there. Both of these are positive. So they're both greater, and you put the greater first. So a bigger number minus a smaller number gives you a bigger number both ways. I would say no to this. I'm going to go with B. Okay, so we do see a big difference, but how would we know? How would we wouldn't be able to like say it's because of that thing. Because of what they were talking about. Okay, let's do the next problem. An SRS, front sheet, okay, crashes. You have people who were in seatbelts that got killed. Okay, so we have not wearing seatbelts and we have seatbelts. And effective in reducing fatalities. So reducing fatalities. So you have, so if you were going to reduce, effective in reducing fatalities, then the proportion of people who that wear seatbelts and get killed would be, I'm going to write my null here, my alternative. Okay, so we just have to think about what this number means. We have 33 over 2819. These people were all wearing seatbelts. And then we have 13 out of 7, 8. Sorry, these were not wearing seatbelts. 13 out of 7, 8, 8, 6 were wearing seatbelts. So they want this number to be less than this number. Or the not wearing seatbelts would be greater than the people who were on seatbelts. So let's see what we want to go do. Consider the first sample to be the sample of not wearing. Okay, so that's going to be important. So of not wearing. So this is no seatbelt versus seatbelt. So take a second and see if you can figure this. This is not seatbelt. If they're not wearing a seatbelt, it should be greater. The death rate should be greater if they're not wearing a seatbelt. So that's what this sentence right here gives us. We have to know the order of what they're in because they want this number to be bigger than this number, which means that it would be greater than. Okay. So that's going to turn out to be this one. So you have to know the order because it could be less than, and it could still be correct. Okay, so let's go ahead and run the test. It's the same test. You're going to do stat. proportion test, 2 sample summary. Okay, remember the first sample that I'm going to put in are people that were not wearing their seatbelts, which were 33 over the 2,819. And these were the people that were wearing their seatbelts, which was 13 over the 7,886. We want this to be a greater than, and compute. Okay, so we're looking at a z of 7. If you look at those percentages, they were a lot different. That's why we're getting this big z value. Okay, so what I did here was I took this value, the 7, and I rounded that 0 up to a 1, because that's how rounding works. Okay, this p-value, I'm just coming over here. It's less than 0.001. 3 decimals, that's 0. Okay, the p-value is less than. 0 is less than 1%. The p is low, the no must go, so we're going to reject it. So there is sufficient. There is evidence that the rate of the people of death not wearing seatbelt is greater than the death here. Okay, to find the confidence interval, I'll just go back here, edit. Okay, so on this one, they didn't tell us the confidence level. So there's a formula on your, if you watch the video, there's a formula because this is a one-sided test. So defined what confidence level you have to do 1 minus 2 times the alpha, 0.01. Okay, so make sure you go back and watch that to figure that out. So this is a 98%. So 0.98. That seems kind of small. I thought this was going to be a larger difference, so put it around a 3. Okay, that's 3 decimals there. Okay, so I'm here and I'm gonna, that 8 rounds that 8 to a 9. Yeah, I knew something didn't seem right with that. Okay, 1% alpha. This is a 2-sided test. Okay, I found my problem, and my problem is I rounded this wrong. That 9 should round that 4 to a 5. Okay, now whenever you get a confidence interval for 2-sided, you're looking for 0. So this one does not conclude 0. So if it doesn't conclude 0, we think that there's a difference. In this case, they're not equal. These are both positive. Okay, for those not wearing a seatbelt, we think it's higher. Okay, so I'm not going to do 4 and 5. It's going to be like the, sorry, I didn't think. Okay, this seems like seatbelts are associated with a lower fatality rate. Okay, now I'm not going to do these next two. It's the same exact idea. It's the same, it's all the same thing, the same idea. So just make sure that you watch the first 3 and you get a good hang of it. Okay, let's go 9.2. 9.2 is a 2-sample t-test. Okay, to be a two-sample t-test, they're dependent if they're paired. We did that on the video. Okay. Okay, so these are independent because you got two different groups. You got groups of men, you have groups of women. They have nothing to do with each other, so they're not paired. They're not related. Okay, now let's go ahead and do a test. Whenever you have two different samples that are not related, they're totally independent, we do either a 2-sample t-test or a 2-sample z-test. For the most part, it's going to be a t-test. Okay, data on the weights of contents of cans versus contents of cans of regular. Okay, so the how much is in, or what's the weight of a diet versus the weight of a regular? Is there any difference? So go ahead and pause it and make sure that you read the video and you understand what's going on. Whenever you read these things, I'm looking for a claim. So right here, less than. They think the diet soda is less than the regular soda. So this would be the diet soda. This is the regular soda, and I think it's less than. The less than is going to go in your alternative. And then the regular soda, the equal, will go in your no. Okay, so that's going to be boom, right here. Okay, now when you make your decision to run your test, you're looking at this data and you're looking for, do we know sigma or do we know S? In this case, we know S, so this is going to be a t-stat. If it was sigma, it'd be a z-stat. But it's not sigma, it's S. Okay, so we're going to come over here. It's going to be similar to what we just did. We don't have the data, we have a summary. Okay, so the sample mean is going to be this guy right here. 0.79393. I'll go ahead and just put the data in real quick. Okay, there we go. Just make sure you pause the video and look at where I'm getting these numbers from. Okay, so now my alternative, that needs to be a less than, and we are ready to compute. So that is -16. I think that'll work now. Okay, round to 2. Okay, good. This is going to give me a p-value of 0 again. Oh, something went wrong. I probably have something in wrong. Okay, I'm going to take a second to figure out what happened. And voila, I found the problem. Instead of having 31, I actually have a 41 in there. So you could see it's easy to mess up these numbers sometimes. So maybe it's a good idea to run it twice just to make sure, or always double check your data to make sure you don't make the mistake. Okay, so this looks better. Okay, I'm gonna round to 2 digits and that should be better. Oh, so, I forgot the negative about this. Okay, final check. There we go. Okay, the p-value, that's really small. That's 0. Okay, now let's do all the interpretants fun. Okay, so what are we going to do? We're going to reject or fail to reject. Well, that 0 is less than 5%, so we should be rejecting. Whenever we reject, we have sufficient evidence of what the claim that the means are lower. Okay, so whenever you reject the null, we're thinking this H1 is true. Well, that H1 is saying that this weight is less than that weight, statistically. Okay, so now we need to construct the confidence interval. So this could be a little tricky if you don't watch a video and you don't know the formula. I'll just tell you the formulas right now. If it's a two-sided test, let me write this down here because this could stay. If it was a two-sided test, which means that H1 is a not equal to, here's your formula, 1 minus alpha. If it's one-sided means your H1 is either greater or less than, and it's 1 minus 2 times alpha. So that's how you get this is your CL level. So I'll just leave that up because they're not going to tell you. You're going to have to know how to figure that out. So do not go put all the data back in, just hit options edit and all the data will show up here. Okay, so now I need to change the confidence level. I have to figure out the confidence level, which is based on this alpha. Alpha is 0.05. This is, if you remember, the H1 is from the claim, which I don't have, but I think they said it was, actually I can figure it out from here. Claim that it's a less than. It's right here, lower. Okay, so it's 1 minus 0.05 times 2. That's 10%, so this is 1 minus that's 90%. So I need to change this guy right here to a 90. And that part is a little tricky. It's going to take you a little bit to get. And there was a negative on this side right here that it didn't pick up. Okay, we need to go to three decimals here, 3. So 0.025. Here, 0.0. And there we go. Okay, so now does the support, is it the same? I'm looking for 0 here. Okay, it should, because only negatives. Okay, so we just rejected the null. The null is that it's equal to 0. Well, if you have two negatives and 0 is not in the interval, that supports the same decision. Okay. And okay, proctored versus not proctored. Okay, test the claim that students taking a non-proctored test have a higher. So your H1 is that the average for the non-proctor is higher than the average from the proctored. And then this would be that they're the same. Based off this data, can we say that we think it's true for everybody? Okay, so that's going to be that one. Let me make sure. I think that they're looking at this one. They just have it backwards. We had this problem before. So they're looking at this one as being the first and this being the second. So if I had switched these things around, these subnotations, if I put proctored here, so you see what I mean? What if I put proctored here, because that's first, and proctored here, and then I put not proctored and not proctored? Okay, so if that was not proctored, and the proctored would be less than. So that's, I think, what they're doing. They should have been a little bit clearer on this, who they put in, because the way that they asked the question, you could have put non-proctored first and put a greater than sign. That's kind of sometimes the problems with doing these on calculators. Okay, so what this means is we have to put the proctored in first when we do this. As the data. The data for the proctored has to go in first, and this is still a t-stat. Okay, so I'm going to go ahead and enter the data in. I'll be right back. Okay, so I'm back with the data in. So take a second, pause the video, and just look to see how I transferred that thing over. Sometimes students, they don't know the notations. They don't know that x bar is the average. So make sure that you're clear on that. Now this needs to be a less than, because we have the proctored first, and we have the non-proctored. So negative 2.81. And hopefully this comes out good. P-value 0.0035. Which I'll round that 3 to a 4. Just round this 3 right over here to a 4 because of that 5. Okay, now what we need to do is make our decision. So this 4%, or sorry, this 0.4%, that's 0.4% is less than that alpha. So we are going to reject the null hypothesis. Whenever you reject, we have sufficient evidence that the non-proctored is higher, that the non-proctored is higher than the proctored. Okay, follow up. This is going to be the same alpha as the last problem. This is a one-sided test. So if you look at here, we're using this formula over here, 1 minus 2 times alpha, that's 5%. 2 times 5% is 10%. 1 minus 0.1 is 0.9. So I put the 0.9 in there. Here's my intervals. These intervals basically tell you how much less they expect somebody taking the proctored test would get. So if you take a proctored test, they think you're going to be 18, close to 5 points less. You go 2 decimals there, 2 decimals here, which means I need to make a change because that rounds. Okay, now does it support the conclusion? So the conclusion is that proctored, that non-proctored will be higher than proctored, or proctored will be less than proctored. And this is a yes, because the confidence interval does not, or only negatives. They're both negative. Okay. Now, anytime, this would be the last one we do for here. So they have these eruptions of a geyser. This is like the time in between the thing exploding up. And so we have to actually, we don't have to put the data in, good. So what we could do is open up the data, they'll put the data in for us. Okay, perfect, that makes this a lot easier. Now, does it appear that the mean time has changed? So when it says that, they don't give us a normal claim, but they're saying, has it changed? Well, we don't know if it's changed. Change would be a not equal to. So it's going to be that one. Something could change and get more, and something can change and get less. Well, we don't know if it's less or more, so we don't know which way it changed. Okay, so this is going to be a t-test. In this case, we have data. Okay, we have our data in. So I'll do recent first because they put it first, and then past second. This will stay because that matches that. And that's it. A lot of people question why we have to get the t-statistic, because the p-value is really the value that makes the decision, but it's always important that we get the t, because it tells us how many standard deviations our sample result is away from the null. Okay, so the 3 digits, we're going to go with 0, 4 here. I'll just throw a 0 there for fun. Okay, so now we need to make a decision. We're going to use an alpha of 10%. So we have to look at our p-value, which was 0.04, and our alpha at 10. That's less than that, so we should be rejecting. We want to reject the null because the p-value is less than significance level. There is evidence that the mean has changed. If you reject this is how it works. Eventually you'll get it if you don't have it yet. If you reject this, we think this is true. What does this mean? This means that they've changed. They're not the same. It's a not equal to sign. Not equal to sign means that that they must be different. Okay. Now, would it change our conclusion if we did a 1% versus a 10%? So here's your 10%, and we rejected the null. Now, what if it was a 1%? Well, in this case, that'd be greater, so this would be a fail to reject H null. So it would change it. If you read through these, it looks like this second one's going to be it. I just read it wrong. It's rejected when it's not rejected when it's rejected when it's 10%. So HO is rejected when the significance is 10%, which I have right here. This is 10%. I just read it wrong. That's 10%. That's 1%. So when it's 10%, it's rejected. So H null is rejected when the significance is 10%. That's true. And not rejected when it's 1%. Here's 1%, and it's not rejected. So this will be right. So what happens when you try to go too fast? Okay, so we've done at least 3 of those type of questions. So let's move on to the next one, so it's not so long. We're going to go on to 9.3. And this doesn't change. This goes through kind of it goes through everything. This formula works for everything we're doing today. Okay, so we have paired data. This will always be an equal to 0. Okay, now I'm looking for some sort of a claim here. Males speak fewer. Males speak fewer. And okay, so let me show you how to do this. Let me get rid of this real quick. So the claim, males speak fewer. So we need to look. We're looking, did they do males minus females or females minus males? If it's this, it's going to be a less than. If it's this, it's going to be a greater than. Males minus females. So if this was fewer and this is more, then fewer, a number that's small minus a bigger number gives me a less than 0. So you have to kind of pay attention to the order that they put them in. And it's 0 because if every pair said the same amount of words and we got the difference between every pair and then averaged them, it would be 0. For example, if I said 10,000K and my wife said 10,000K and you had 15K, your partner had 15K, and they were the same, all these differences would be 0. So mu d would be equal to 0 if they talk the same. Well, if all the males are fewer and all the females are more, then that would be that'd be a less than. Okay, so to run the test, we're going to have to open the data. These paired tests are always run as the data. So we have to open the data here. So I just hit that box, open it up, and so they think this column overall is going to be less than this column overall. This is another t-stat, but this is paired because these are all couples. Males in the first column, females in the second column, and that this should be a less than. Okay, so here's the t. It's not too significant. We need to go to 2. That rounds that 2 to a 3. Okay, the p-value is sitting over here, 0.06. Okay, let's see, 6, and how many did I go? 3 decimals, so that'll go to 0.067. Okay, now let's check our alpha level, and I'm just trying to make my decision. This is my p-value. Now my alpha level is 0.05. This is more than. This is the p-value. This is alpha. If the p is more than the alpha, we fail to reject. Okay, whenever we're not rejecting the null. So if we're not rejecting the null, we don't have evidence that the guys speak fewer words. Okay, to get the confidence interval, everything's the same. Just back, edit, keep everything the same. This was a one-sided test. Alpha was 0.05. Okay, because they don't tell us what level to find, so we need to find the level. So this is a one-sided test, so what we're going to do is in this formula right here, so 1 minus 2 times 0.05 will give me 0.9. So I need to get rid of this 5. So this is how much fewer guys talk than girls. And 0 should be in the interval because we failed to reject. They flipped it. They went to 1 decimal. Technically, I don't need the 0 there. I'm just putting it there. Ooh. Okay, I'll figure out what's going on. Okay, and I think I just had a rounding issue. I think this should go up to a 6. There we go. Okay, so what feature of the composite leads to the same conclusion? We're looking for 0 in the interval. 0 is in that interval. If you start from a negative and go to end at a positive, you went through 0. So we should be found to reject. Okay, we'll do one more of these. Okay, so I'm going to skip to the next one because that looks like the same problem. Okay, we did that one in the video. Okay, let's check. This is the effectiveness of hypnotism in reducing pain. Now the reason it's a paired test is because it's 2 results on the same person. So that's a person right there, that's another person, this is a person. So these are all people getting 2 results, a before and an after. Okay, we want to do before minus after. We want to do before minus after and do a confidence interval. So we go stat. This is a t-stat, and it's a paired. Let's do before, second after. We want a confidence interval. Okay, so we need to go 2 decimals. And voila. Okay, so whenever, to be effective, 0 can't be in the interval, because if 0 is in the interval, then the average difference could easily be 0, which means there's no difference. So since 0 is in the interval, we can't claim that there's a difference. Okay, this is something about speed dating, 5 attributes. Okay, so let's run through this because I only did another one. So this has to do with ratings by males and females. So this is how they rated each person. So that's why it's a pair, because they like rated each other. They're not independent. So this male rated this female 33 and the female rated that male 26. Okay, so in a perfect world, they would be equal. All these values on the left would be the same as the right. So here it must be that the guy liked the girl more than the girl liked the guy. Here it seemed like the girl liked the guy more than the guy liked the girl. The note says the guys like the girls the same. Okay. Now I'm looking for a claim that there is a difference, See, there's no greater than, there's no less than, that's a not equal to. There is a difference. So that means there's a difference. Okay, let me just open this in StatCrunch real quick. Okay. Let me try something real quick. I was trying to get the to add these two, to subtract these two, just to get the actual differences, just to see overall, did one gender prefer the other gender. I'll be able to see it after I run the test though. So this is a paired T. Okay, we'll put the males first, females second, just because that's how they gave us the order. This is all right, and now all we have to do is compute it. So what this means is this 0.16 means the guys preferred the girls a little bit more, but not a whole bunch more. Okay, so 6 is going to round that. So I think we're going to go with 0.20. And the p-value, which should be pretty large, really large. Okay, I think I got my rounding right there. Maybe not. Oh, sorry. I have 2 8s there. 845. Okay, this is a really large p-value. This p-value is greater than the significance level. If the p-value is greater than the significance level, it's going to be a fail to reject. Remember, if the null is high, if the p is high, the null will fly. So this means there's not evidence to support the claim that there's a difference. Okay, so that's I did a little bit of each one, which should be really helpful. I appreciate you watching, and hopefully it helps. Thanks.